Yesterday we just talked about finding the discriminant. How many zeros we have. What we're going to talk about today are imaginary numbers. If r is less than 0, then the square root of negative r is defined as the square root of negative 1 times the square root of r. The square root of a negative we call I. It's imaginary. It does not exist, but we could actually find the square root of the number part. For example, the square root of negative 25 is 5i. We usually use a lowercase cursive I. The square root of negative 6 is I square root of 6, because the square root of 6 is not a perfect number. Right. No, square root, it's I square root of 25. Now, if I take the square root of a negative 1 times the square root of a negative 1, what's negative 1 times negative 1? Positive 1. And the square root of 1 is 1. Right. So you just said this would be I, and this would be I, right? I times I is I squared, which means it's actually 1. If you multiply two i's, the i's disappear. It's a negative and a negative. If it was a square root of negative 5 times the square root of negative 5, well, you have I square root of 5 times I square root of 5. Well, I square root of 5. So the i's are going to become positive. So it would be square root of 25, which is 5. All right? You can change your calculator into imaginary. Like right now, if I take the square root of negative 25, it says error. And if I say go to, it shows me why. But if I go into mode, down here, real. Those are real numbers. If I go over to where it says a plus bi, and turn that on, square root of negative 25 says 5i. The calculator can do i's. So if you want to change it over, you can do so. That's what i's are. That's the only thing it does, is it allows you square roots of negative numbers. Like Malik said, negative 5, square root of negative 5 times the square root of negative 5. Oh, sorry, I messed up. What happened? No. It's negative 1. Should be negative 1. I messed up there.
So that one up here, negative 5.
Yeah, this would be negative 5. I messed up on the i's. I's times I is negative 1. All right? I times I is negative 1. Now, complex numbers is just a combination of real numbers and imaginary numbers. Complex numbers are always in the form of a plus bi. A is the real part. B is the imaginary part. You're always going to have an I attached to the end. We're going to find x and y such that 7x minus 2iy is equal to 14 plus 6i. We have two different parts here. We have two variables, right? We have the real parts and the imaginary parts. They're separated. So I have 7x equals 14 on the real part. On the imaginary part, I have negative 2i y equals 6i. Which, when you're just talking about the imaginaries, you don't need to put the i's if you don't want to. But you can't forget about them. Just remember you're talking about imaginaries. What's x over here? 2. What's y over here? Negative 3. So the answer is 2 minus 3i. Divided everything by negative 2. Yeah, and I got negative 3. So it's 2 minus 3i. Yeah. If I had it in here, you don't, since you're just talking about the imaginaries, you don't need it there. So x is 2, y is negative 3. We don't have to put them together. Because we were just looking for x and y. I was going a little bit further. I want you to try this one. To solve this, what gets paired up together? 2x and the negative 8 are your reals. And your imaginaries are 3y equals 10. We don't need to put the y or the i's on there. X is negative 4. Y is 10 thirds. So the real part is negative 4. The imaginary part is 10 thirds. Here's this problem. Yeah. Yeah. That's what we're going to do, is we're going to FOIL it. So I have 2 plus I times negative 5 minus 3i. What's 2 times negative 5? Negative 10. What's 2 times negative 3i? Negative 6i. I times negative 5 is negative 5i. And this is negative 3i squared. Because they're lower cursive. The reason why we don't just use a straight up and down is it has a tendency to look like a 1 if you're not careful with the dot. However you want to write your i's so you're not getting them confused with 1s, it's fine. And I can tell if they're i's. All right, I have negative 10. What's negative 6i, negative 5i? Negative 11i. Now I have negative 3i squared. What did I tell you I squared means? Negative 1. I squared means negative 1. So this is going to be plus 3. That's your answer. What's that? Okay. Sorry, I didn't finish. Okay, negative 7 minus 11i. Okay, what's I squared? Negative 1, so it's negative I. If I have I cubed, that's the same thing as I squared times I. That means negative 1, so it's negative 1i. If I had I to the fourth, it'd be negative 1 and a negative 1, which is positive 1. Okay. The conjugate of a complex number of a plus bi is a minus bi. It is denoted as a plus bi with a line over top. The conjugate is used to simplify a fraction that contains an imaginary number. So, for example, we have 2 plus 5i over 2 plus 3i. To solve this problem, or to simplify this problem, we're going to take the conjugate of the bottom. What's the opposite? 2 minus 3i. Whatever you do to the bottom, you have to do to the top. Because what's 2 minus 3i over 2 minus 3i? 1. I haven't really done anything to the problem. Because you're using the bottom. You only worry about the bottom part, the denominator. Now I FOIL on top. 2 times 2 is 4. 2 times negative 3i. 5 times 2, or sorry, 5i times 2 is 10i. And 5 times negative 3i. Negative 15i squared. On the bottom, 2 times 2 is 4. 2 times negative 3i, negative 6i. 3i times 2, 6i. And 3i times negative 3i, negative I squared. Negative 9i squared. Now we're going to simplify. All right, I have 4. What's negative 6i and positive 10i? Plus 4i. And then I have I squared means negative 1 times the negative 15 gives me positive 15. That will be on top 19 plus 4i, yes. On the bottom, I have 4. What's negative 6i and positive 6i? 0. What's negative 9i squared? 9. So plus 9. What happened on the bottom? There's no more i's. That's what the conjugate does. Gets rid of the i's. And 4 plus 9 is 13. To change this into a complex number, 19 thirteenths plus 4 thirteenths I. Broke it apart to change it into a complex number. Formula? There is no formula. Oh, a plus bi. Complex numbers have to be a plus bi. I want you to try this one. To simplify this fraction, I need to use conjugate of the bottom. What do I put in the parentheses? 2 minus I. On the top, 6 minus 3i minus 8i. On the bottom, now I'm going to simplify the top. 6 minus 11i minus 4. Signs are the same, so I add. On the bottom, 4 plus 1. Because I squared means negative 1. Negative times negative is a positive. I'm going to simplify. 6 minus 4 is 2 minus 11i all over 5. I'm going to write it as a complex number. 2/5 minus 11/5 I. It's not on the bottom, it's out to the side. Try to write 11/5 I. Yes. I squared is negative 1. Okay? Negative 1 times 4 is negative 4. We can graph imaginary numbers. This is the complex plane. Instead of having x's and y's, you have the reals and the imaginaries. It's a complex plane. It's a complex graph. So look at your real number. 3. 1, 2, 3. What's my imaginary? 2. This would be 3 plus 2i. That's it. That point. It would be the point 3, 2. But you have to understand how to graph imaginary numbers. In Algebra 1, we talked about imaginary numbers. Not yet. Now this is the time. To find the absolute value, you can use the Pythagorean theorem. If I'm talking about absolute value, what does absolute value mean in general? Okay, not talking about signs. What does absolute value really tell me?
How much it really is?
The distance on a number line to 0. Absolute value basically means how far is it from 0. If you had negative 5, how far is it away from 0? How far is negative 5 from 0? 5. How far is 6 from 0? 6. Now for this one, if I want to know what's the absolute value of 3 plus 2i, I want to know how far it is to 0. If I'm looking at my graph, that's 0 right there. How far is it from there to there? It's not 3/2. 3/2 would be your slope. Actually, no, your slope would be 2/3. Rise over run. But if I look at it this way, how far have I went here? How far have I went here? How can I find out how far away? Pythagorean theorem. What's Pythagorean theorem? A squared plus b squared equals c squared. So in other words, to find out c, the hypotenuse, we just take the square root of a squared plus b squared. Well, a is the real number, b is the imaginary number. So if we're talking about, what was it, 3 plus 2i. If I wanted to find out what's the absolute value of 3 plus 2i, I just take equals the square root. What's your a? So I have 3 squared. What's your b? 2 squared. 3 squared is 9. 2 squared is. Put it together. Do you know the square root of 13? Can I simplify it? Then I'm done. That's what it is. That's the absolute value of a complex number. It's just the real number squared plus the imaginary number squared and the square root of it. Find the absolute value for negative 3 minus 4i. To find out the absolute value, all I do is take the square of the first one plus the square of the second one. 3 squareds, 9, 4 squareds, 16. Put it together, I get 25, and the square root is 5. So the absolute value of negative 3 minus 4i is 5. That means if I was to graph it, that means I go negative 3, negative 4. That's the point in the complex plane. The distance from here to here is 5.
So that's how you do it on the 4 centimeter acid. This is like for Jordan's house, 17 miles.
I don't get that wrong.
But those problems, you're not talking about complex with imaginaries. You're talking about triangles in Pythagorean theorem. That's the end of this lesson. We got through complex numbers.